In this video, we're going to look at what kinetic energy is and show you how to calculate it using the equation. Now, the kinetic energy of an object is the energy that it possesses due to its motion. So anything that's moving has kinetic energy, whether it's a plane or a particle. How much energy an object has, though, depends on two things: its speed and its mass. For speed, the faster an object is moving, the more kinetic energy it will have. Which kind of makes sense, because if you think about any fast-moving object, it must have had lots of energy transferred to it in order to speed it up, and that energy is stored in the kinetic energy store. So fast objects have lots of kinetic energy. Meanwhile, for mass, as long as everything else is kept equal, for example, the objects have the same speed, then the more mass an object has, the more kinetic energy it will have. So if our particle weighed 0.1 grams, but our plane weighed 20 tons, and both of them were traveling at 900 meters per second, the plane would have much more kinetic energy, because it has a much larger mass, but the speeds are the same. What if instead, though, the plane was traveling at 5 meters per second, and the particle was traveling at 4,000 meters per second? In order to find out which object had the most kinetic energy this time, we'd have to use the equation, which states that EK equals 1/2 mv squared. If you're not familiar with this equation, the E stands for energy, and the little k means it's kinetic energy. Then m is mass, which we measure in kilos, and v is velocity, which for the sake of this question is the same as speed, and is measured in meters per second. So as with any question, once we have our equation, the next step is to make sure all of our values are in the correct units. So we have to change 20 tons to 20,000 kilos, as there are 1,000 kilos in each ton, and we need to divide 0.1 grams by 1,000 to get 0.0001 kilos. And we're now ready to plug these values into our equations. For the plane, we do 1/2, or 0.5, times its mass of 20,000 kilos, times its speed of 5 squared. And remember that it's only the speed that's being squared, not the entire thing. So that gives us 250,000, which will be in joules, because we measure energy in joules. And we could rewrite it as 250 kilojoules, as the K just means 1,000. Meanwhile, for the particle, we do 0.5 times 0.0001 times 4,000 squared, which gives us 800 joules, or 0.8 kilojoules. So even though the particle was traveling much faster, it still had less kinetic energy, because its mass was so much lower.